synopsis of the pros and cons also we can see on this webinar, and also what is the impact of by implementation of this biopolyol in the polyurethane application, and also we can see, and as a technology biopolyol producers, and also I would like to present how we are preparing this kind of biopolyols, and also related to that some of the polyurethane application case study also I'm going to present in this webinar. And the last but not least, and the recent trends in the biopolyols and the polyurethane application along with the challenges. From this way, I want to conduct this webinar, today's webinar. As introduction, what are biopolyols? You know that one. Biopolyols is nothing but the polymeric alcohols. It is by using the natural resources. Natural resources means but plant-based sources. Compared to in normal the fossil-based polyols is based on the petrochemical source. That is the thing. And the main purpose of the biopolyols is going for the polyurethane application, like the insulation foams and automotive sections, coating industry, sealants industry, adhesives industry, and all kinds of wherever the polyurethane is goes, and all the polyurethane application it can be suitable. And also where this biopolyol can able to exist in the market, because this kind of thought came in the early 2000 years, because of due to increasing the environmental awareness, and this kind of environmental awareness is increasing a lot, and due to that one, the biopolyol strength is driving in a steady growth, and also everyone is looking for the sustainability steady. Okay. And then the biopolyol, what is the importance of biopolyol? Ultimately, biopolyol helps for the carbon dioxide emission, and also because of we are using the plant-based source, the plant-based plant, as you know, the plant always absorbs that all the carbon dioxide. By the way, it will reduce the carbon dioxide emissions. And what are the types of biopolyols involved? Because normally, you already know the polyol feedstock for the polyurethane application is two types. One is the polyether type and the polyester types. But here I'm talking about the types of biopolyol means it's based on that because the feedstock anyway we are going for the going to use the plant source. Okay, anyway, plant source also the different types of plant source is available. Based on the plant source, the types of the biopolyols also little varies on that one. For example, vegetable oil-based polyol. Directly, we can use as a oil as a feedstock to make this biopolyols like castor oil, soybean oil, rapeseed oil, tall oil, whatever the oil is there. And then the second type is that we can use that fatty acid derived from the oil, and that fatty acid also can able to use it for that to make that biopolyols. This kind of biopolyols, the fatty acid biopolyol, is best suitable for that flexible application for automotive and adhesives. And the last but not least is that if you want to go for the rigid form biopolyols, then you have to go for some high functional biopolyols is required. That high functional biopolyol you can get it from that some high functionalized nature of that feedstock. That high functionalized nature of the feedstock comes from the sugar and the glycerin. These are the commonly available of the different types of the biopolyols in the market for the different polyurethane applications. And okay, we can go and see for the types of feedstock. Okay, the types of feedstock, as I mentioned earlier, vegetable oils and fats are one of the types of feedstock for making the biopolyols, and also the second one is the biomass waste. Biomass waste, you know that one, sugarcane baggage, that is also one of the biomass can convert into the biopolyol by the two-stage liquefaction methods. One is biochemical liquefaction and the thermochemical liquefaction method. By the way, they are converting this biomass into the biopolyols. This also nowadays is in the trending market of biopolyols. And then the last one is the algae and microorganisms. This algae and microorganism polyols also is now this is the aquatic. You can find it. This kind of is the aquatic region. This aquatic one is as a good source of that biorenewable material. From the algae also you can convert it by the influence of the glycols or glycerin, and by the using of the liquefaction. By the liquefaction, we can make it into the biofuels. From the biofuels, we have go for the reduction process to make that this kind of biopolyol also. And what we can do before going for the processing of the biopolyols. The processing of the biopolyols, the first and foremost important is that the right selection of the raw material. we have to go for the right selection of the raw material for choosing for the biopolyol. What application we are making for the biopolyols? We have to first aim it for that one. We have to put it for first and foremost forward is that what application we are making going to make the biopolyols. So we have to choose the right raw material suitable for those application. That's the thing. And also, what is the sustainability and what is the uh, uh, how can it be functionalized in that application? That is the thing we have to do. We have to take care. And then second point is that we have to get the whether that the particular feedstock is the consistent quality and consistent quality of consistently available in the market and consistent quality can able to get it or not. That we need to ensure it. And the third is that whether that particular feedstock based product is the economically viable and it will create some environmental impact or not. These are the three points we need to first to concentrate before processing of the biopolyols. And then the second point is that what type of chemical conversion we are going to take place for to convert the plant-based renewable based feedstock to the biopolyols. That is also we need to consider. Okay, the chemical conversion process we can see in the next slides. And then the last one is the refinement and purification. The refinement and purification is also important, not only on taking the converting the biopolyols, but biopolyols, there's a lot of byproducts and the side reactions also involving on one. In this kind of things, we have to get purified to make the quality products for that right polyurethane application. That's the thing. After finishing the conversion of the biopolyol, we need to distillation, filtration, and also either way chromatographic method by by this way of filtering of also required on this one. And also we need to ensuring the performance and also safety of the final product. This is the conversion and synthesis of the biopolyols. The first and foremost is the esterification and transesterification. The transesterification is very simple. Is the vegetable oil we have to convert with the help of the glycol. We can make the transesterification. The transesterification you can make the product called monoglycerides or diglycerides of fatty acids. This fatty acids it can react with this fatty acid because as you know the esterification requires the one acids and the alcohols to make the condensation reaction. This fatty acids reacts with the glycols. It can produce that biopolyesters. Biopolyester. This is the one of the method of conversion conversion and synthesis method of the biopolyol. The second one is the hydrogenation followed by the hydroformylation. Not only an hydrogenation because this hydrogenation process, what we have to do is whatever the things unsaturated fatty acid from the vegetable oil, it converted to the saturated fatty oil. This saturated fatty oil, you have to go for that one. You have to make with a reduction reaction to make that biopolyols. That is the second method. The third method is the ozonolysis. Ozonolysis is nothing but infusing of the ozone to make the product to make the dicarboxylic acid. That is the method of the ozonolysis. And the last but not least is already everyone is using is a epoxidation method by the oxidate ring opening agent. The help of the oxidate ring opening agent followed by the hydroformylation will get the biopolyols. And then we can see the pros and cons. And foremost, everyone knows it's a renewable sources. This is the main advantage of the biopolyols. This derived from the plant-based origins. And by implementation of this kind of renewable resources, we can reduce the dependency of the traditional petrochemical sources. And also at the same time, it will also supports agricultural economies. That is the main advantage of this by implementation of biopolyol. And the second one is that it is the lower environmental impact. That is reduced greenhouse gases, and also important thing is it is a biodegradable because petrochemicals are not biodegradable. This is plant-based. This is fully biodegradable end products. You can able to make it. That is a important in the nowadays the environment. Right? And the last one is it is lower toxicity compared to. And also, not only on that one, not only on the green type of things, some of the plant-based sources also it will help on that on the property enhancement what we are not getting in petrochemical sources. That is also we can see in the next slide. And it has a greater resistance to wear and tear properties, and also it has the improved low temperature flexibility. Because commonly for the polyester polyols is not low temperature flexibility. using the petrochemical. By using this kind of plant-based sources, we can able to achieve this low temperature flexibility, property, and durability. That is the main advantage of this biopolyol implementation in the polyurethane. And then we can see the disadvantages. Disadvantages, we know, everyone knows is okay. Anyway, because whatever the new product is coming into the market, or something is a new innovation is coming to the market, is always involves a high initial cost, high cost of that product. Because anyway, okay, whatever the gaps presence in the early 2000, but not in the year of nowadays, the gap is already reduced. The cost by petrochemicals and those products. This is the one everyone is seeing as a disadvantage of implementing biopolyols. And then the second disadvantage everyone is seeing and saying is a limited raw material availability. Yes, of course, crop season. It depends on the crop season. Then only it will be the right slope of the feedback, the feedstock, and then also instead of we have to use on the food products, edible source, we have to go and concentrate for the non-edible source. Then we can avoid this kind of raw material availability issues to overcome.
Hello.
And also, yeah.
Hello. Sorry to interrupt, sir. Sir, many the participants are telling that your voice is not audible to them.
Now it is fine, Snega.
Sir, for me it is fine, but for them I am not understanding. Yeah, someone is telling please you use headphones. So
Headphones
you have
only I'm using.
yeah. So for
I'm using the headphone.
Yeah. Okay, so participants, please tell if it is okay.
Is it okay?
Hello, Mohit ji, Atul ji. Yeah,
in
okay.
Between, in between, voice is going low.
Now it is fine, Atul.
Now it is.
Yeah, it's fine. Fine. You can go ahead.
Now it's fine. Can I proceed?
Yes,
please.
Yeah, please.
Yeah, fine. Okay. The last disadvantage we are seeing is the technical challenges and in processing method also. Because it's not some of feedstock, for example, biomass waste, it involves a lot of process of first we have to convert into the bio oils, and from the bio oils we have to convert into the biopolyols. From the biopolyols we need to filtration of the impurities. This kind of lot of stages of that lot of production stages is involving. Due to this one, we need to challenges in processing a right biopolyol for that our desired polyurethane application. And we can see for that what is the environmental benefits by implementation of the biopolyol. I already mentioned this is the reduction in carbon footprint and waste minimization. That is the important thing. Waste minimization is important thing because in petrochemical source, how we are minimizing the waste, not like that in the biopolyols. Because the petrochemical source or whatever the products, polyurethane products, for example, if you are using for the visible forms, okay, we are using even reproduct forms. And for example, for the rigid forms, okay, we are using it in the coal as energy, coal as a replacement of the coal energy, and also if we can this kind of coal replacement of that rigid form products, we can send to municipal incineration for converting as a energy. But this kind of process, it will involve a huge capital cost and large operating cost. So it is not viable for that one. But if you are using it for the biopolyol, we can waste minimization is happening because whatever the product base is biodegradable. That is the only one thing. This is the one thing, and also by using the glycolysis method, we can reuse of this one. So in this way, minimizes the waste and also we are maximizing the renewable resources. It will directly contributing to our circular economy. And what is the regulatory policy? Yes, of course, because some government incentives and support will aim to promoting this kind of biopolyols and sustainable practices. And also, as you know, because as a bio-based feedstock has some reduced GST, that is can help. And also, Indian government has announced something like the PLI production incentive production. Hello. PLI program for that one for the biorefineries, applications. Same way, this kind of incentives and supports can able to promoting this kind of sustainable practice in the pollutant segment. And also we need to follow the international guidelines and standards to framework the whatever the complex requirements involving in the biopolyols and the pollutant application for the for the development projects. And also compliance certificate also required. We have to go for the third party certificate. Third party certificate for the verification for the biocarbon content. How we can testify the base because they are the standard like kind of ASTM standard D686. This is the bio-based carbon, how much the presence in that one. We can promote this kind of the data. It can be promoted to the customer end to implement this kind of biopolymers in the pollution. And also, not only on ASTM, and also in Europe also, they have the standard called 16785, and 16575. These are the two standards. 16575 is based on the only for the bio-based carbon and 16785 it is based on for that not only on the carbon. We can find out that nitrogen, what amount of nitrogen is there, nitrogen is there, biohydrogen is there, oxygen is there. By this way, we can able to promote to the to implement biopolyols for the pollution applications. And as you know, we already seen the biopolyols versus petrochemical polyols. This is the okay. Anyways, the one it is the life cycle we can compare of that one because it has a longer life cycle biopolyol has, but petrochemical source is not like that. And also, it environmental aspects also the biopolyol is better. And also the some performance and durability also is somewhat the biopolyols is on the linely marginal compared to the petrochemical source. And also it has a long-term solution for that one for the pollution industry. And we can see our biopolyol process methods. The technol biopolyol process method, as we are always following the transesterification and esterification only. As I said, just only we are using with the glycerin, we can with the monoglycerides. This monoglycerides fatty acids or triglyceride fatty acids, we are converting into that as a polyester by implementation of the glycol ester. And the second method we are using also direct esterification because the bio-MEG also is available in the market by using of the biorefineries. They are making we can put the biodiabasic acid as I mentioned in the azelaic acid type of things. We can use directly that one into the condensation reaction to make that biopolyol. And we can see, okay, some of the case studies in the insulation industry, and first I have to show some of the general insulation how the technol biopolyols is performing. Because normally if you want to go for that rigid foam application or general for the rigid foam insulation or PUA applications, you have to go for that functionalized biopolyol only is required for this application. This functionalized biopolyol at least minimum of 4 to 5 functional is required. Minimum at least 3.5 functional biopolyols is complete is more suitable, more viable for to use it in the rigid applications. That's what our technology 8206 is. The functionality is around 4.2. This is best suit for that for this kind of applications. By using that one, you can see that one Orenol 490 is a petrochemical source, the southern based, and the 7315 is a 20% biocarbon bio in the polyester polyol, and the technology 8206 is that 80% biopolyol bio content presence in biopolyester. If you can see this formulation, you can it's just a general guideline formulation. If you can see that one, if you are using with the 70% of that biopolyol is one along with that petrochemical source, it gives a good compressive strength. You can see that one in that example 2. The example 2 gives the good compressive strength and also the lower thermal conductivity as well as the dimensional stability is not much changing in the volume change. It's a good dimensional stability. So it can able to compare with that one, the petrochemical source, it can have the good one. So what is the advantage of that one petrochemical source means? If you can see that one, it has the if you are using the 100% without any bio content in the only petrochemical source of polyol, if you are using like that one, then you will get the layer separation by using that hydrocarbon and doing it. And using the hydrocarbon and doing it. And also it is not also sometimes it can be able to if you are using the high water content also, you will get some layer separation you are using. So this bio, if you are implementing this kind of bio nature into that your polyols, then you will get that some hydrocarbon solubility because of the hydrophobic nature, and also whenever the water content is high, then it has a good solubility with water. And then if you can see that panel application, this panel application also the Signal 8206 plays a key role, and also it gives a good property in the compressive strength as well as the thermal conductivity as well as the dimension stability. And one more question is that biopolyol suits for the PAR foams? Because everyone knows the PAR foam is completely aromatic polyester polyol plays a key role. But the biopolyol is aliphatic nature of that one. How can it be else of the vegetable oils? Yes, we have the solution for that one. By the inclusion of the aromaticity in that biopolyol, bioaromaticity, then you can use this kind of polyols for the PAR applications. The source of the biopolyol is you can use that CNSL oil. It has aromatic nature, and also you can use that tall oil fatty acids. This kind of oils can able to give some aromatic nature of that aromatic fatty acids. This aromatic fatty acids you can use in the implementation of the biosource in the biopolyols. For example, and also the one more is called furan dicarboxylic acid. The furan dicarboxylic acid also you can use it as a direct source, but that one is the cost wise is not at all economical. So you people can consider to go for this kind of CNSL or this kind of tall oil fatty acids based on what. For example, if I'm using the 64 kind of is based on the CNSL base, this CNSL based polyols, it gives a good aromaticity. I'm using for the 100% example 1 and example 2. It contains with that along with the 7325. 7325 is the general carboxylic acid base, and then along with that some of the aliphatic nature of the polyol also. Combining, you are using the aromaticity is in the polyol. You can see that one on the flame resistance. You will get that good in the only that DIN 4102 B2 flame items only for getting this centimeters. So using for that, if you are using with that polyether polyol along with that one the petrochemical based dicarboxylic acid polyols, then you will get that flame resistance is little higher than that whatever that aromaticity presence in the polyols. That is the one advantage if you are using the aromaticity implementation in the biopolyols. And also it also a good compressive strength, and also the thermal conductivity is okay, is comparable with the petrochemical source, and also it's a friability. Friability is an important one here because some of the people is operating the PER needs the temperature to convert the trimerization, but some of the markets not having some heat sources, so they will operate like a PER conditions. Yeah, with some PER condition, if you are operating, friability is a main issue, and it will by existing the friability, you can face the adhesion issue in the panels. But if you are implementing this kind of biopolyols, the friability is you can reduce the friability. You can operate the primer also, the PER also. You can operate PER conditions. And the second case study is here. We can look on that one, the flexible slab stock foam application. This flexible foam slab foam application, I'm taking the conventional polyether is a 3500 molecular weight triol and a 3000 molecular weight triol. And along with that, ethanol bio 2670 is a bio dicarboxylic acid base. Is a bio dicarboxylic acid base is good source of because it's a fatty acid base. This fatty acid is always good for the flexibility and durability also. This polyol, whenever I'm implementing the biopolyol along with POP and the 3000 molecular weight, you will get the maximum air permeability. Whenever the good air permeability, you will not face any issues on the foam linkage and compression state, mainly on state properties. You see that the implementation of biopolyol along with POP, then it will the compression is very low. That is the good sign of bio by the implementation of the bio. The hardness also good. Hardness also is higher when compared to the other examples. and also if you can see the tensile strength also very high, and elongation also good, and elongation as well as the tear property. And the second case study in the flexible nature is the viscoelastic bun stock. The viscoelastic bun stock, if you can see that one, there is only, I am converting that bioconvert is a 1000 molecular weight. Technol 150 BP is the 1000 molecular weight biopolyol, and 250 BP is the 700 molecular weight biopolyol. Because these polyols only F1000 is the conventional 1000 molecular weight trial polyols, polyether polyols. That one I'm taking this kind of polyols for this kind of for particularly for this viscoelastic case study. If you can see these examples, by seeing these examples, you can see that one example 2 is getting a good properties, because the example 2 is having that both combination of the 1000 molecular weight and 700 molecular weight, and it will give the good is the low recovery time, fastest recovery time. Fastest means it's not a moderate, medium recovery time, and also it gives the hardness also is nice, fine, and also the tensile strength also is okay, is comparable, and elongation is good. Elongation is good, and the tear resistance also is comparable and slightly increasing in weight by implementation of that 1000 molecular weight bio and with the along with the 700 molecular weight of biopolyols. And then my last case study is that in the footwear application. Yeah, because footwear, as we all know, the footwear in footwear application, the polyester polyol is what is the drawback of the polyester polyol implementing in the footwear application is that one is a bad hydrolysis resistance. By implementation of the biopolyesters into the footwear industry, then you can overcome this kind of hydrolysis resistance. You can able to face a good hydrolysis resistance like how the polyether polyol is there. That is the one main advantage of implementing the biopolyol in the polyester division, particularly on the footwear applications. You see the technology FW75 is the biopolyester, and if you are implementing, and also you can make this kind of biopolyester use along with that conventional polyether polyol, petrochemical polyether polyol. You can make it as a hybrid system to have the properties of both polyester as well as the ether-based system. What you are getting. The same way we are seeing that example one, the Shore is okay. Shore is 55 as like the polyether system, whatever the market is available. And if you are implementing along with that this kind of polyols along with the pop, you can increase that hardness properties. And also for the relative volume loss, abrasion resistance is good in that one. In that only with the polyester polyol along the C1445 is the petrochemical source of polyester polyol, and technology FW75 is the biochemical source of the polyester polyol. This if a combination of the biopolyester petrochemical source of polyester, you can able to get a good, you can get it in a good abrasion resistance. You can get the relative volume loss is very low. And also we can see that hydrolysis resistance after 1 week and after 2 weeks. If you can see that one after 1 week and after 2 weeks, whenever if you are implementing that one, the properties doesn't change much. That is the main advantage of the biopolyol implementing into the footwear applications. And these are the biopolyol characteristics what I have used in this case study. 8206 and 6340, 734 and 5. These are the aromatic nature of the biopolyol. If we are these three polyols we have conducted this case study in the rigid form application. And 2670 150 2670 150 PPO and 250 PPO we guide this kind of dicarboxylic acid fatty acid biopolyol using it in the flexible and the memory systems. And FW75 we conduct a case study in the application. And let's see what is the recent trends of the biopolyols. We can, because a lot of the recent trends is that I already mentioned in that one ELS studies, there's a synthesis techniques method. Synthesis technique method, there's a novel bio-based polymerization method. There is the enzymatic methodology. Enzymatic methodology also came to the market. And by the enzymatic methodology, the catalyst also, because normally we are using the homogeneous or heterogeneous types of catalysts in the market. in the market is available, and also we are also most of the people are consuming type of catalyst only to make the biopolyols or to make normal petrochemical sources. But there's a enzymatic catalyst also that came in the market, and it will give the higher efficiency of the product, and also it will give the faster reaction rate of the biopolyols. And also, if you will get the for the yield is 90%. If you are using the enzymatic catalyst, then you will get that the yield is around more than 95%. That is the benefits of this kind of enzyme catalyst. And also we have to integration with biopolyols that needs to include biorefineries. For example, we can see that by integrating of the biorefinery models, for example, biobutanol is producing in the biorefineries, combining biobutanol production, the production of other biochemicals like the biofuels or bio-oils from the same feedstock, improving that our overall resource utilization and economic viability. This is the way. This is the advantage by integrating the biorefineries with the biopolyols, and also what is the sustainable trends? What is the new sustainable trends? As we already discussed, circular economy approaches. Circular economic approaches is most important for the bio-based polyols. It is an economic model. It will it will be using for the renewable natural resources and minimizes the waste. In context of the biopolyols, circular economy be applied by reusing the materials like sawdust and used cooking oils to produce the biopolyols and biopolymers. This, this is the way maximizes the renewable resources, maximizing the using of the renewable resources, minimizing the wastage. That leads to the circular economic. And then the carbon footprint, everyone knows that this is the plant-based source, and it reduces the carbon dioxide, it becomes the carbon footprint. And what is life cycle assessment improve? Because the life cycle assessment is must for the bio-based polyols. Because the life cycle assessment, it is nothing but is frameworking the evaluation of the environmental impact of the product or service through its entire life cycle of the product. It is used to assess the environmental efficiency of the bio-based product and the biorefineries. And what are the stages involved in the life cycle assessment process? There is a lot of things. From the raw material extraction to processing, to the second stage is the manufacturing of the product and packaging, and the third stage is the using the product during its entire lifetime, and the last stage is the disposing of the product at the end of its useful life. These are the 4 stages involving in the life cycle assessment methodology. And also there is nowadays there's a lot of software also came to assess this model, like Cyma Pro 9.0 and Eco Inventory 3.5. These are the softwares enabled to find out that to assess this model, life cycle assessment model for the biopolyols. And what are the challenges? We have the technical challenges with the feedstock variability. That's why we can't, because there's a lot of feedstock is there, because not only on oils if you are taking in account of the oils, soybean oil is there, castor oil is there, and palm oil is there, rapeseed oil is there, and sunflower oil is there. This kind of oils is there. We have to choose here right feedstock and for the right application. That is the important thing. And also if you have to and also make it concentrate on the consistent quality of the feedstock. And the second one is the conversion efficiency. Conversion efficiency also we need to take care, because what type of conversion method we are using to convert biopolyols. That is the challenges for this one, technical challenges. And also the scalability issue, because nowadays there are a lot of invention is going for the bio things. Even that bio isocyanate also came. The bio isocyanates also for furan based and CNSL based also came. This kind of invention is going on from the lab scale. But if you're converting it to the industrial level, it involves a large capital cost and huge capital cost, and large scale operation is involving. This kind of issues, technical challenges are involving for implementing of the new innovations of the biopolyols and bio things, and what is the market challenges? Of course, because we need to compete this biopolyols compete with the petrochemical polyols. The first and foremost is the price issues there. Anyway, okay, whatever the prices is there, but in sooner or later, once all the consumers are regularly using, this price gap will be reducing. And also the supply chain limitation, because that's what I initially tell. We have to improve. We have to choose for the non-edible source of biopolymers. Because now non-edible, because edible source, it goes to the food chain industry. This food chain industry is very difficult to get it, and we have to go for the non-edible source. Then we can get it here double fish apple chain of this one. And also the consumer acceptance and awareness. If we go for the consumer knowledge, we have to engage the engage consumers and give the sustainable program practice to the consumers and get awareness among them. That is the way to implement on that one. And also, this is the one of market challenges for implementing. And last but not least, the what is the future market is there? The future market innovation is going on with bio also this bio catalyst also is coming up. This kind of markets are there, and also constantly all the peoples are focusing for this bio product. In fact, you've seen that one globally. Globally, I mean, in USA only, is involving is consuming more types of biopolymers. And the next stage is that European regions, and this region is called Africa. Because as the Indian peoples, we are also increasing our global consumption of the global biopolymer consumption from yearly 10% is increasing. Yearly 10% is increasing. If you see kind of the globally, is our compound annual growth rate is 10.24% from 2024 to 2020. This is the forecast the market people said. And also yearly is 8.8% is increasing year by year more rate of this biopolyol development. And what is the importance of the ongoing research? Because this is not like that once it's developed is stopped like the biopolyol. The biopolyol type of things is going day by day is going for the new research and new things and new innovations is coming in to make it in a competitive in the market, not only on the economical wise and also as the quality wise and also to meet the performance wise also. And also the policy and regulations. We are looking for some good policies and regulation to encourage this kind of biofuel producers and also further to supply to the biofuel. And also last month is encouraging sustainable practices to our consumers. That is the most important thing. We need to encourage and improve implementing the eco-friendly methods for the long-term benefits of this kind of biopolyol sustainable practices. From this way, I can able to wind up this one. If there is any question and answer, I can able to answer for that one.
Sir, there are
Snega?
two questions. Yeah. Sir, first of all, thank you for this informative presentation. And there are two questions in the chat box from Mr. Atul Sarang.
Yep.
He wants that you please share the range of hydroxyl values which can be attained in the biopolyols. And the second question is, please also share the functionality ranges.
Functionality ranges. Just a moment.
Yeah. Hydroxyl values and functionality ranges.
Can you see Snega?
Yes, yes, yes.
Okay. This is the hydroxyl value. Hydroxyl value of the for rigid is 435. The A206 is 435. And then its functionality is around 4.1. And the 6340 functionality is 4.1. And then 6340 is that hydroxyl value is 3.350 and the functionality is around 3.8. And 7315 it's 2.2 functional and hydroxyl value is 315 only.
Okay, so functionality is not mentioned in this slide, right?
Yeah, in this not mentioned. I'm telling now.
Okay. Yeah.
Whatever the things.
Yeah. Thank you. So, hello, Mr. Sarang, are you there? Hello, Atulji.
He's in mute. He's on mute.
Yeah. So He has said thank you on the chat box.
Any other
And
questions, Nigam?
yeah. Next question is, how much biopolyol is currently being consumed in the Indian market?
It's the Indian market is consuming is I don't have the exact data
Yeah.
on that one
Okay.
because it's annually is growing. The prediction is growing is that Indian market is consuming is around 10% every year. It's increasing the biopolyols.
Okay. Okay. So no number in consumption, but the
I
growth
don't have the
is
consumption. The growth is 10% for every year.
10%.
10 to 15% every year. 10 to 15% every year.
Okay. And there are two more questions. Any manufacturer in India for biopolyol? Of course, Polyol Technologies is one. Any other if you know?
No, is lot of people are the Giant Agro. They are making as a castor oil polyols.
Right.
Giant
Right.
Agro is making the castor oil polyols, and some people are making this also. But what we are specialized for we doing means we adapt some functionalized one, and also we are making this kind of biopolyols for the application to application, not only on a single feedstock.
Okay.
We are making with that multiple bio feedstock for making this kind of biopolyester.
So like castor oil, palm oil, and what are the others?
Like castor oil is there, palm oil is there, and tall oil is there, sunflower oil is there, corn oil is there. Lot of oils are there because this kind of oils, different fatty acids content is present. What type of fatty acid, when what fatty acid is helpful for that our right desired application, we have to choose and we have to make that one.
Okay. The next question is, what is the bio content in these biopolyols?
Yeah, in this bio content, 8206 is contains, I already mentioned, is around 80%. 80%. 6340 is not like this. 6340 is only 60% is there. 7315 is contains only for the 20% of the bio content.
No, so what exactly is the meaning of bio content? I mean, you are
It's a biocarbon. It's bio content is the bio source, bio renewable sources also is there. Bio content is that. Biocarbon is different. Biocarbon is we have to evaluate as per the ASTM standards.
No, sir, he is asking about bio content only.
Bio content,
not
no?
biocarbon. Yeah.
Okay, bio content is that is the one 80, 20, and 80, 60, and 20.
So if you have a T7315 as only 20%, how can you call it as a biopolyol? The textbook says that, true to its word, the biopolyol should have approximately 83%.
Yeah, of course. This is the 80% is okay, but the problem
It
is
is
that
okay. It is okay, and so also your 634
no.
gives
Actually,
60.
yeah. Your good name?
I'm Murli Mohan.
I'm only Mogan. Yeah, it's right. Of course, because now that market is not paying that much of costliest product. That's what we are implementing some 20% because not only on we are adding that only not only on the bio things. This bio sources or bio content helps for the some of properties like hydrophobic acid plus the ALS side. For that application, we are implementing this kind of 20% in the normal petrochemical source, so that the price is also not much like this is the starting stage because implementation is also actual market challenges is there on the commercial viability. For that purpose, we are implementing this type of polyols also we have available to encourage at least some source of the bio going into the polyurethane application.
Okay. Now, in which segment does this biopolyol get maximum sold? Is it in the rigid forms or is it in the
No, mainly
molded
goes
forms?
for the flexible slab stock. Flexible slab stock is there, and also it goes maximum in the memory also. And also the second thing is the coating application. Coating application, coatings industry is using a maximum bio content. Because a lot of
did you share any? Sorry, did you share any screen? I mean, any slide on coatings?
No. I'm not included in the coatings one because it's already because the time constraint. I have not shared that one. In future, if there anything is there, I will share the things about this one also.
Okay. Thank you.
Thank you, Molly.
So are there any more questions? Yeah, there is one. Foam made up of biopolyol can be considered as biodegradable. Can
Yeah,
it be considered?
it's partially because the still the isocyanate comes from the petrochemical source.
Hi, Bernard, what is the approximate cost of these biopolyols?
Which one, Mr.?
Grades, I mean, all these grades range for the benchmark price.
Your good name? Your good name?
Saronan from Manali
Saronan.
Petrochemicals.
Saronan. Saronan, actually, this kind of A206 is okay. A206 is actually the present price we are selling in the market is around 160 to 170 rupees.
Okay.
But 7315 is competitive
Mm-hmm.
because 7315 we are selling it in the market is 118 to 125.
Okay. Okay. Thanks.
Any more, Snega?
Yeah. So next question is usage of biopolyols in viscoelastic foams reduce temperature sensitivity in the resultant foam. Is till what ratio we can incorporate biopolyol in viscoelastic foam formulation?
60 to 80.
Yeah. So this question was from Harshi Jaiswal. Harshi,
60
are
to
you
80.
there?
Yes, ma'am.
Yeah. So
That is,
60
I'm
to
talking.
80.
I'm actually I study in the slab stock one, not the one molded one. The molded one, it requires for that presently there is I have the data of 30% one, 30%.
Okay, so she was asking about viscoelastic. So we can
Viscoelastic
take it as
molded or this one slab stock.
No, slab stock viscoelastic
Yeah,
foam, sir.
slab stock you can use it for 60 to 80.
okay. So are there any more questions? Yeah. So one more question. How can we calculate the bio content in the foam produced with biopolyols?
No, it's the bio content is mainly for that water, how much that renewable resources, and directly as a into that universe stoichiometric formulation is the one bio content. If you want to go for the biocarbon, you have to go for the testing method only. Hello, it's based on that how much bio renewable sources presence in your the final yield of the polyols. Based on that one,
Okay.
not on the
Okay.
whatever the input is based on the yield.
Okay. And then the next question is, does it affect any other footwear property? I mean, negative effect on any property.
No, actually, that's what I said. Biopolyol, it's not predicted one. Based on the formulation you are trying to actually, yes, you can't able to replace that this kind of biopolyol apple to apple source one. You need to find little fine tune of the catalyst part, we little fine tune on the what is the combination this biopolyol along with one the other polyester polyol, conventional polyester polyol or conventional polyether polyol you are using. That is the tricky part. That is the technical challenges involving on that one to without compromising any properties, and also at the same time to get that your desired results for the especially on that hydrolysis resistance.
Okay. Okay, so I think there are no more questions.
Is there?
Yeah. So yeah, so there are no more questions. So let us thank Mr. Bernard for this informative presentation. And he described right from the scratch, from the polymerization processes till the end, life cycle, etc. So thank you so much, sir. Thank you so much for investing this time for our
Thank you,
benefit of
Snega.
biotech
Thank you,
industry.
Snega, and thank you, IPUA, for this wonderful opportunity given to us.